Hi everyone, welcome to this PV Tech webinar with JinkoSolar. I'm Will Norman, I'm Senior Reporter at PV Tech and I'll be moderating this session. I'm joined today by Shane Lee, who's the Senior Product Manager at JinkoSolar, to discuss the company's innovations and advances with its Tiger Neo 3 TOPCon modules. We're going to hear from Shane in a moment about the modules, after which we will have a time for question and answer session with input from the audience. First, I'm just going to set the scene for a couple of minutes. The rate of change in solar module technology is increasing as the industry continues to grow the world over. Manufacturers are constantly looking to develop products that meet real-world demands of the rapidly expanding solar sector, whether it's harsh weather durability, low light performance, power output, efficiency, or often all of the above. And far from tinkering in the margins or theorizing, pushing the capabilities of solar modules has increasingly significant implications. The world is approaching a so-called terawatt era of PV deployments, where the technology represents a really significant portion of our power mix. Sorry, I think we're getting some interference there. And solar at the same time is being built in more diverse locations and climates. At that scale, improvements to performance, lifespan, or efficiency have real impacts on energy generation and economics as well, and finance. There are some key factors which we'll address today, which have increasing importance for optimizing solar's performance in the field. First of those is bifaciality. Bifacial modules offer greater performance. They offer greater performance and can significantly increase the share of sunlight the panels can absorb from either side. Bifaciality, therefore, also plays into low light performance, which is of growing importance. A module which can function well for more of the day or in a wider range of weather can make for much more valuable and productive solar assets in more locations around the globe. Various current and next generation technologies we know about, TOPCon, back contact, HJT, are vying to prove the best low light performance. This all sort of comes under the umbrella of overall operational efficiency. In the figures that we see, 25, 24% pushed around by all of the major manufacturers. And the way that more efficient modules can reduce the LCOE, the levelized cost of energy for solar projects, which is already the lowest cost tech in much of the world. This is fundamental to the economic growth and future of solar energy. So having set the stage like that, let's move on to the main event and have enough from me. So Shane Lee, Senior Project Manager at JinkoSolar, is going to present now about the Tiger Neo 3 modules. Please remember, there will be a question and answer session after Shane's presentation. So if you have any questions, there's a questions button on the bottom right of your screen. So put your questions in there and we'll get to as many as we can. Thanks for listening, and over to you, Shane.
Okay, and it's very glad to see you anyone just in this webinar. And this is Shane Lee from JinkoSolar Technical Service Center. And it's very glad to meet you anyone in this webinar. And as we know, JinkoSolar officially released the Tiger Neo 1.0 product in the November 2021. And in the following several years, JinkoSolar has invested a lot of time and resources into the research and the development of the N-type. And we continued to cultivate into the field of TOPCon technology. And then we successfully released the 2.0 products and the latest one, 3.0 products. So such a specific and advanced type of product, how efficient will it be? And why it can be so popular with the market? So today I will give you the answer. And my topic will mainly focus on the core technology of the Tiger Neo 3.0 product and its advantages. Especially, I would mainly focus on its superior performance in low irradiance conditions. So firstly, let's have a quick look on the key factors that our Jinko has already achieved. Jinko is the global first company that achieved 320 gigawatt module shipment. And we have gained 6 times #1 in yearly shipment. And one more, if you see in the right corner here, It shows our 2024 global market share, which is 15.5%. It means that on the global project side right now, there is 1 out of every 7 panels are from Jinko. And so why we could gain so much high award achievement from the market, this is thanks to our R&D efforts. We are constantly setting new industry benchmarks. Until now, our cells and modules have broken world records 30 times. Notably, the efficiency of our N-type cells has reached an impressive 27.02%. And our N-type modules efficiency has also achieved like 25.58%. So let's start our main part. And today I will give including like 3 parts. And the first one would be about our TechNews 3.0 technology.
Sorry, Shane, I'm just going to interrupt you. I think that the slides are not displaying properly.
It's all good now?
Okay, has that fixed it, everyone? I think that
Um,
should have fixed it.
no, I think I already shared.
Yeah. Okay, no, we're fine. Sorry, just wanted to make sure that everything was working. Apologies for that. Okay, carry on.
Okay,
I'll be quiet.
Okay. Let me share. So the coin technology that used in the TechNews 3.0 are mainly including the following 4 technologies, which is the first one like the ME, metallisation enhancement improvement. The second one is MAX, and the third one is MCP, and also the last one is the FP, multi-cell technology. And I will give you the introduction one by one. For the first one, what is metallisation enhancement changes? It can improve the cell contact interface so the electrons move more easily into the grid. And the cell efficiency has increased by 0.5%, which translates to the approximately like 5 to 10 watts of additional power for the 66 type module. And also this ME technology has been proven its excellence, no matter passing the triple IEC reliability test and also with a good field test result. And moreover, we will use the update ME technology into the 3.0 product, which means the cell efficiency will be further improved around like 0.1%. And the second one is the MAX technology. It is a patent enhancement process that optimizes the backside polysilicon layer and also the silicon nitride layer, so it can improve the product performance in 3 ways. First way is like lower the contact resistance and the parasitic absorption, which increase the short circle current and improve the cell efficiency. So it can result in a module power increase of 4 to 5 watts.
Sorry again, Shane. Sorry to interrupt you. I think the presentation isn't moving on. Maybe you need to be moving it on yourself. We're still on key factor slide.
I think I've already.
Okay. Yeah, that's moved on now.
Yeah, that is the MAX technology. Yeah.
That says leading edge technology. Yeah.
Yeah, it's the
Okay.
Okay. So the second one is the MAX technology, which is a pattern enhanced process and optimize the backside, especially for the polysilicon layer and the silicon nitride layer, and improving the product performance in 3 ways. First is lower the contact resistance and the absorption of the parasitic, which increase the short circle current and improves the cell efficiency. So it can result the module power increase of 4 to 5 watts. And the second one is it can optimize the film thickness, which reduce the power sensitive to the environment and improve its weather resistant. Third one, it can optimize the rear side design, which reduces the irradiation loss and increase the bifaciality, further enhancing the module's power generation capacity in the real world use. And then is the third technology, which is named multi-card passivation, which is also named MCP technology. This is a further improvement from the half-card cell. As we know, there is a microscopic damage in the process of scraping the cell. such as the physical cracks. These problems will have a negative impact on the performance of the PV module. Through development of the MCP technology, the age of the cell is strengthened passivation treatment. Effectively repair the cell defect in this age. It can reduce the carrier recombination and increase the power of the module by more than 5 to 10 watts. And the fourth one is the FP technology, which is also a quarter size cell instead of the previous product, which is used a half cell. And it is a brand new technology for the Technew 3.0 product. And this means that this is not ever used in the Technew 2.0, or no matter the conventional one or the advanced one. And it just looks like the advantages brought in when the entire cell switched to the half cell in the past. So when it used the FP technology and plus the MCP technology, the power can get extra more than extending due to its lower internal power loss, and its single cell size is much smaller than the whole cell or the half cell. And the last one is the optimized interconnection. It is a new, flexible, and soft contact technology. It has been introduced into the string process, which can significantly reduce or even eliminate the inter-cell stress, thereby avoiding the risk of the inter-cell minnow cracks. And the latest soldering equipment uses more precise alignment systems and gently welding parameters. So by finely controlling the key parameters like the welding temperature, time, and pressure, we can greatly reduce the risk of the minnow cracks caused by the thermal and the mechanical stress. So these are what the technology will be included in our Technew 3.0 product. And then let's move to the second part, the advantages of our 3.0 product. I thought that you may have already knew this product in some other webinar or any other sources, because we have already launched this Technew 3.0 series products in the SNAC, and it is a much higher power product, incorporating with all the technologies I have mentioned in the first part. And this module achieves an impressive power output of up to 670 watts, and with a conversion efficiency of 24.8%. And its several advantages and higher generation make it well suited for a wide range of applications, especially for the ground situation and the large-scale distributed generation scenarios. So by comparing with the Technew 2.0, our Technew 3.0 product has the following advantages. The first one is the power temperature coefficient. With each generation of the PV technology, the power temperature coefficient has steadily improved, and the Technew 3.0 series featuring an industry-leading coefficient of -0.26 instead of the -29, taking the TOPCon technology to the next level in the thermal performance and energy yield, especially under some high temperature environment and conditions. The second advantage is the bifacial factor. While the P-type modules and the back contact modules have hit a plateau, Jinko's TOPCon technology continues to push our bifacial performance further. With the Technew 3.0 reach over like 85 bifacial factor, we offer not only a better real side gains, but also a higher constancy and bankability on the field test conditions. And as you know, each 5% of the bifacial factor increase, it can achieve more than like 0.6 generation gain for the ground situation project. And if the higher albedo of the ground situation it is, the higher generation gain will for our Technew 3.0 product. And the third one is the advanced warranty. Our 3.0 products features a lower annual degradation of 0.35 instead of the 0.4, which means there will be more guaranteed energy over the 30 years. And it delivers not just a higher performance, but also the higher confidence, ensuring long-term energy yield and bankability, which means that your investment covered by our industry-leading guarantees. And the fourth one is the better anti-shedding behavior. Due to the FP technology and the brand new circuit layout that used for our 3.0 product, it can directly improve our anti-shedding performance. Here you can see with the same shedding scenarios shown in the picture, if there is one short column cell that be shadowed, then from the left picture, which is the other main product in the market, it will have a 83% remaining power. But when you look into the Technew 3.0 product, it will still have more than 90% remaining power. So it means that our Technew 3.0 product can produce about 8.3% more power through this same shedding scenario. And the fifth one, the last one, is the better low irradiance performance. So before our starting the advantage itself, we need to know one concept, that the probability of the low light or the low irradiance occurring is very high and occupies the majority of the whole day or whole year. So relative power performance of the module in a low irradiance environment is obviously important, which is actually and closely related to the benefit or the generation of the solar project. And as we can see from the first table here, the low irradiance test shows that the Jinko TOPCon modules outperform with the HBC products. And if we take a look into the diagram and the bar chart below here, the relative performance of our TOPCon module can achieve an advantage of 1.8 to 3.6% by comparing to the back contact module, especially under the low irradiance conditions, which is the 200 watt per square meters. So in conclusion, Technew 3.0 has been fully upgraded with the following several advantages. The first one is much higher power and efficiency, which can reach to 670 watts and 24.8. The second is the power temperature coefficient, which increased from the 0.29 to 0.26. And the third is up to 90% bioefficiency. And the fourth one is the more reliable warranty for optimized energy degradation. The last but not least is the improvement on the anti-shedding behavior. The last one is the better low irradiance performance, which can produce a higher relative power at low light conditions. So with these advantages, the project with our Technew 3.0 product will have a more optimized performance. And also, this 3.0 product can be ordered from 2025 Q4. And also the first product delivery will also at the same time. So before we officially start with the part 3, let's have a quick look about the video, which is showing the real environment and to know how the low irradiance performance.
Hello everyone, it is July 24th and it is 3 o'clock in the afternoons. I'm at a field test station in Jiangsu, China, where we'll be comparing Jinko TOPCon versus the latest anti-BC technology. I will be showing you the low irradiance characteristics of Jinko TOPCon and its advantages over anti-BC technology. Later, we will show you the real-time generation data of both TOPCon and BC products to show you the low irradiance advantages of TOPCon modules. Later, we'll be using this data collection device to capture our irradiance, current, voltage, and power output. Now I'm standing next to the data collection box, and now the time is 4:55 p.m. Beijing time, 30 minutes before we experienced a little rain, and now the light is starting to dim, so let's check out the low irradiance performance of TOPCon modules. So around 4:20 to 4:30, we experienced some rain. So let's just pick a time to see whether how TOPCon performs. So let's say 4:25 p.m. Jinko TOPCon generated 651 watts, while BC modules only generated 577 watts. So this is equivalent to a 12.8% generation gain. And now let's check at the present time. The irradiance is currently 339 watts per meter squared. Jinko TOPCon is generating 3,123 watts, while BC is generating 2,715 watts. So this is equivalent to a 15%. So this shows that TOPCon's low irradiance performance is superior to that of the BC products.
It is now 6:46 p.m. Beijing time. The sun is about to set, and the light is getting weaker. Now is the biggest test for the modules. Let's first look at the operating power of the two types of modules. I am now capturing the data at the 641 mark. Jinko TOPCon's real-time power is 95 watts, while the anti-BC's power is only 79 watts. That's a 20% gain in between. The real showdown begins now. Who can catch the last ray of sunlight? Who can hold on until the end? Let's wait and see. It is now 4 a.m. We are now going to the field test station to check on the morning's power generation situation.
Now it is 4:49 a.m. We're back to the field test station, and we'll see whether Jinko TOPCon or anti-BC modules would first generate electricity. It is currently July 25th, 5:07 in the morning. We can see that the inverter is starting to operate. So let's see which of the two module types is the one that is contributing. So we can see at the 5:01 a.m. Jinko has a output of 7.2 watts, while BC only has an output of 1.4 watts. This means that Jinko modules is the first to generate electricity in the low light condition. Okay, so 20 minutes has passed, and now the time is 5:26 a.m. Now let's check how the modules are operating. So at 5:23 p.m., we can see that Jinko TOPCon's output is 74.6 watts, while the BC output is only 58.8 watts. So now let's simply calculate the generation gain of TOPCon over BC. We can see that the generation gain is 26%. So this means that TOPCon modules can outperform BC modules in low irradiance conditions. Okay, now the time is 5:37 a.m. Let's check out how the modules are performing. You can see that TOPCon's output at 5:32 a.m. is 135 watts, whereas BC only has 116 watts. So after some simple calculations, we find that the generation gain is 16%. Okay, so this concludes our visit to the Jiangsu field test station, comparing Jinko TOPCon modules versus anti-BC modules. So from yesterday's data and today's data, we can find that Jinko is the first to generate in early mornings and late evenings, and we can generate more in low irradiance conditions such as early mornings and late evenings, and even in rainy days.
Okay, thank you guys just watching the video, and I think after the video you got to give a further inspection about how the low light performance better for our TOPCon modules. And then I will give you more information about the technical outdoor performance. Okay, firstly, as the video said before, the advantage of the low irradiance performance. And we also set some other real outdoor field tests to see how much it can really perform better. And this field test is conducted by a third-party institution, the CPVT, which is also an accredited testing center in China. And as you can see from the left table, it shows the overall generation per watt within different irradiance. And the data covered for a whole year is from the December 2023 to the December 2024. Just see this red circles data, which is under the low irradiance condition. And this is because considering the irradiance below the 400 watt per square meters. And then taking a look at the right table here. The total generation below the 400 watt per square meters for each cell technology. It shows that our TOPCon has the highest generation. This is mainly because what we mentioned before, the TOPCon has a better relative power rate at the low irradiance. So the power generation is also high. Compared to the HJT or the A company's back contact product and also the B company's back contact product, our TOPCon has a generation gain at like 2.0 and 15.5 and also 10% more than the other cell technology products at the low irradiance conditions. And also for the overall at all irradiance, our TOPCon also has a very higher power gain like 1.6 and 3.3 and also 1.7. And besides this few tests mentioned, we also done some other tests. And this is the comparison between the N-type BC with our TOPCon modules. And the generation gain shows that our TOPCon module can produce 1% more than the N-type BC product. This is also conducted by the third-party institution, which is located in the west-north of China. And if we take a further inspection for the real data of this project, that we could know for the total generation comparison in the June, and we considered in two perspectively. One is the low irradiance performance. This first one is like about the proportion of the power generation on the low irradiance conditions, which shows it can occupy more than 24 of the over irradiance. And another proportion is the generation time under the low irradiance condition, which shows it can occupy like more than 50%. It means the majority of the whole monitoring period is on the low irradiance condition. So the low irradiance performance is a key factor for the module generation evaluation. And our TOPCon can have a much better gain during these conditions, which is like around 1% to 4% generation gain per watt based on the different internal irradiance. And to be more specific, if we take 2 normal single days to have a look on the generation data, shown in this right bar chart, when it is a cloudy, we can see that during the morning time from 6 to 9 o'clock and the afternoon time 17 to 20 o'clock, which is also on the low irradiance condition, our TOPCon module can have a 3.89% generation gain than the back contact product. And also it's same as in the sunny day. So it's same as in the sunny day, even in the morning or in the afternoon time, we can have a 2.33% power gain. So this means no matter in a cloudy day or in a sunny day or in any weather, because the majority of the monitoring time is on the low irradiance, so our TOPCon can well have a better performance during this time. And besides the field test in the Ningxia, we also have conducted a field test in Hainan and cooperated with another third party, CGC, which is the environment is for higher humidity and higher temperature. Then we also set a comparison group between our TOPCon and N-type BC modules. And the generation gain shows that our TOPCon module can produce 5.11% more than the N-type BC product. And for this project, we also consider the generation from 2 perspectives. One is based on the bifacial comparisons, and we do the actual test on the third-party lab. It shows that our TOPCon can have a 14% more than the back contact products, especially on this bifaciality factor. And also, this can get a 50 watt more power for the rear side. And then it can get a 1.54% for the generation gain. And another is based on the low irradiance comparison. We also gathered that the duration of the low irradiance happened during the monitoring period, which is over like 40%. And within this period, our TOPCon can produce like 7.83% more generation gain than the back contact product. So why we could achieve such higher generation gain in the field test data? The above are the highlights of the product advantage from a data sheet and also the key factor perspective. By comparing the mean performance parameters of these three products, we can find that the Techneo 3.0 has significant advantages in 4 aspects. First is the bifacial factor, much higher than the 2.0 and further higher than the back contact product. And also the low irradiance performance, we can have like 2 and 3% more than the back contact. And also the temperature coefficient for power and even the annual degradation, we can make the same as the back contact product. So to sum up, because these key advantages of our Techneo 3.0 products, as mentioned, each advantage could produce a better generation gain as shown in here. And this is the main reason that we could have higher generation gain like 3 to 3.5% by comparing with this back contact product. So it means that no matter in all the scenario applications or in some like very special cases or special environments, something like the low irradiance environments, our Techneo 3.0 product can also perform the best. And finally, what I want to say more is that our Techneo 3.0, no matter the power and the efficiency, can have a further increase right now, but also it has a breaking future for its development, as Techneo 3.0 has optimized technology input, and its product advantage is more aligned with the application scenarios, both of the utility and the DG market. And that's what I want to share for today. Thanks, everyone.
Thanks very much, Shane. That was really interesting. And apologies to the audience for the technological issues at the start. These things happen sometimes, but I think we got it sorted. So we have a few questions, a couple from me to start with. You mentioned at the start that the Tiger Neo modules have multi-cut cell structures, and many manufacturers have launched similar multi-cut cell products. What makes Jinko different in that regard?
I think it's a very good question. And from the Jinko's perspective, Jinko's core advantage is among similar multi-cut cell products, like in the snake in Shanghai, and from its long-term deep cultivation of the TOPCon technology. And we got the dual guarantee of its mass production system. As one of the Jinko is one of the industry's earliest adopter of the TOPCon, and our accumulated R&D team's foundation supports continues the technical iterations. And this is combined with the major high standard production process and a professional technical team. It also ensures the reliability of the product to be delivered. And this deep synergy of the technical expertise and the manufacturing experience provides the customer with more stable performance and the long-term return guarantees. So this is, I think, the mainly difference between our multi-cut cell products and with the others.
Okay, thanks. We've got some questions from the audience as well, which I wanted to put to you. One from JS Kim, who asks, what exactly, I think they mean technologically, what brings the better temperature coefficient that the Tiger Neo products have?
Okay, it's a really good question. As I mentioned in the slides, that the 3.0 would use a very brand new technology, which is the multi-cut cells. So for the cell itself would be much smaller than before. It means the current with this cell is much smaller than before. So the power loss and also the power for the temperature coefficient would be influenced, like it would be decreased, the influence for this power temperature coefficient, because the current is for the single cell is be lower. So that's the main reason for the upgrade for the temperature coefficient.